What's up, mathletes? We've got section 4.22, graphing polynomial functions. This is day 2, and we've got a special theorem today. It's the intermediate value theorem. And it goes like this. If you've got p of a and p of b that have opposite signs, so let's say p of a is positive, like this value over here is above the x-axis, and this value is negative, it's below the x-axis, then there exists a c value that is in between a and b somewhere where p of c is equal to 0. It's an x-intercept, and it's a 0 of the function. That might sound kind of like a duh, yeah, if it's up here and then it's down there, then somewhere it's going to cross. But it's actually kind of hard to prove, and it's kind of a big deal when you get to calculus, and they use this theorem in some very theoretical ways. All you really need to know right now is that if you've got a value up here and a value down here, or maybe it's the other way, maybe it starts negative and goes positive, then somewhere in between you've got this c value that it also happens to be a 0 of the function, an x-intercept of the graph, a solution of the equation. There are some assumptions. You have to assume that a is not equal to b. Fine. You have to assume that p of x is a polynomial function and that it has real coefficients. If these things are true, then and then if you have this statement, then you know that the c exists. It doesn't tell you how to find c. That would be really convenient, but it just says that c exists. The existence of c is true. So, example 4: use the IVT to determine, if possible, whether the function has a real 0 between a and b. So what you have to do is you have to make sure that one of these is positive and one of them is negative. So for example, you take a and you find f of a and f of b. That's f of negative 4, which is negative 24, and f of b, which is negative 2. And if they have opposite signs, then yes, there is a 0. There is a c value for which f of c would actually be equal to 0. It exists. That's all the intermediate value theorem can say. It only talks about the existence of c, doesn't tell you where it is. b, f of x is equal to x cubed plus x squared minus 6x. Well, you find f of negative 1. That means you plug negative 1 into the function, and you find out that it's 6, and then which is positive, and then f of 3 is 18. That's also positive. Since they have the same signs, then no, the IVT doesn't guarantee the existence of c. I mean, it could exist, but we're not guaranteed that there's a 0 in between 6 and 18. In between negative 1 and 3. Negative 1 would be like right here, and 3 would be here. And since they're both positive, you're not guaranteed the existence of a 0, of an x-intercept. Part C, you've got this different function, g of x. Well, if you plug g of negative 1/2 and g of positive 1/2, oh, that should be a positive, then yeah, you do get opposite signs. This one's positive and this one's negative. And so yes, c is guaranteed to exist somewhere in between a and b. I want you to do D, given that g of 1 is equal to negative 2/3 and g of 2 is equal to negative 8/3. Can you guarantee a c value? I want you to find out, and then after you finish that, start 4b2. I want you to copy the problem list and do the first problem, and I'll see you in class.